If you've ever opened up a science book in school, you probably noticed two trends. The people are usually old, and they're usually men. So today, we thought we'd talk about 3 of today's most influential women in science. First up, Jennifer Doudna. Jennifer Doudna is one of the most culturally significant scientists working today. She helped develop CRISPR, the genetic engineering method that allows mankind to precisely and exactly edit the human genome, potentially unlocking new cures to untold thousands of diseases, like sickle cell anemia, cystic fibrosis, Huntington's disease, and HIV. Even more than that, CRISPR technology can be used to edit the genomes of crops to produce more food, or be more drought resistant. Doudna had a very informative upbringing. Her father had a doctorate degree in English, and even her mother, who was a stay-at-home parent, held a master's degree in education. At the age of 7, she moved to Hawaii, where both her parents taught at university. Growing up on the islands, Doudna was fascinated by the beauty of the island and its exotic plants and animals. This led to her desire to understand the deeper biological mechanisms of the world around her. At one point during her undergraduate studies, she found herself doubting her position in science and almost switched her major to French, but her French teacher suggested she stick it out with science. Following in her parents' footsteps, after attending Harvard Medical School for a PhD in chemical biology, she taught at both Yale and Berkeley. Then, in 2012, at UC Berkeley, Doudna and her associates were the first to prove that CRISPR could be used for controllably editing genomes. Their discovery relies on a protein called CRISPR-Cas9, found in bacterial immune systems. It works like scissors to cut apart DNA from attacking viruses, preventing them from infecting the bacterium. While this system had been known about for years, Doudna was the first to show that the protein could be programmed to target specific genes, allowing scientists to alter genomes at will. While this poses ethical questions, this discovery is also paving the way for countless diseases to be edited out of the human genome. This discovery led to an intense, years-long series of court rulings over who would own the patent governing the research. And CRISPR is crazy precise. The human genome contains about 3 billion base pairs, and CRISPR can be used to target specific sequences as small as tens of base pairs. And it can be used to both edit a single cell that can then grow into an entire organism, or potentially be used across millions or even billions of cells simultaneously. Since her discovery, Doudna has stepped away from the academic world and co-founded Caribou, the company to commercialize the CRISPR technology. Turning from the microscopic to the astronomical, the next on this list is Sara Seager. By the time women were being trained as university scientists, the solar system had been pretty well mapped. Moving past the celestial bodies, Sara Seager looked beyond the sun's orbit into the vast, uncharted cosmos. During her time working with the Kepler Space Telescope, she discovered 715 planets, earning her the nickname the Astronomical Indiana Jones among her NASA colleagues. She's been heavily awarded for developing fundamental techniques for understanding, analyzing, and finding the atmospheres of these extrasolar planets. She even developed a new equation to challenge the long-held Drake equation, used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy, changing the focus to any extraterrestrial life, rather than just those civilizations advanced enough to communicate with us. Originally, the Drake equation focused on searching for rogue electromagnetic waves that might have come from a far-off civilization's radio station. Instead, she focused on searching for planets with biosignature gases, or gases produced from organic life that can accumulate in a planet's atmosphere, like oxygen and carbon dioxide, that can then be detected by space telescopes. Seager now teaches at MIT as a professor of physics and planetary science, hunting for exoplanets that could be habitable for alien life. Back here on Earth, Marissa Mayer has spent her life on the cutting edge of computer science. In 1999, after graduating from Stanford, Mayer received 14 job offers, ranging from a teaching job at Carnegie Mellon to a consulting job at McKinsey & Company. Between the 14 offers, she decided to join a relatively small company as the 20th employee. That company was Google. She started her decade-long career with Google, leading a small team of engineers, developing and designing Google's search system, otherwise known as the number one thing Google is known for. She became known for her attention to detail, which helped land her a promotion to product manager, and later director of consumer web products. There, she oversaw the layout of Google's well-known simplistic search homepage, and she was part of the 3-person team responsible for Google AdWords, which is an advertising platform that allows businesses to show their product to potential customers based on their search terms. which even today makes up more than 90% of the company's $160 billion of revenue every year. She would later become the CEO of Yahoo, tripling their market capitalization, growing mobile users to over 650 million, and building a $1.5 billion mobile ad business. These three women all had major impacts on their scientific disciplines and are still out there doing amazing things. But who will lead the next generation of scientific and engineering women? Only time will tell. Make sure to subscribe with notifications on so you never miss an upload, and remember, there is always more to learn.